Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is differentiating polynomials. Differentiating polynomials is easy when viewed in the terms of coefficients. But when viewed in the terms of the zeros of the polynomial, differentiation is actually a subtle and poorly understood operation. Remember that a polynomial is formed by summing terms of the form cx raised to n, where c is a constant multiplier and n is a non-negative integer. Polynomials are some of the simplest functions we use. We need to know the derivatives of the polynomials such as x raised to 4 plus 3x, 8x square plus 3x plus 6 and 2. Let's start with the easiest of these. The function y equal to f of x, which is equal to a constant. I'm going to take that case first, such as 2. Okay, or it can be any number. It can be a decimal or 1 million or 10 raised to 6, like that. It turns out that the derivative of any constant function is 0. So this makes sense if you think about the derivative as the slope of the tangent line. The slope of a tangent varies depending on the formula for the function, usually called f of x, and the point at which the tangent touches the curve. Please consider this example. There is a graph and 3 lines touches the graph. 3 different tangents in 3 different colors have been drawn in this diagram. Okay, it touches the graph at some point. You have to find the gradient of the tangent by working out the average rate of change or gradient on an infinitely small interval at the point where it touches. Okay, we are now going to find a general method or formula for finding the gradient in any point of a function. So this formula or the new function is called derivative of the original function. So when we find it, we say that we are differentiating the function. The derivative of the function f of x is written using an apostrophe of after the f. Actually, there are many types of notations to denote the differentiation. This is one of the notation. If you want more details about the notations, you can refer our notations video on differentiation. Okay. The notation f dash of x or y dash, both are applicable. Or you can also use the notation dy over dx, which is commonly used. Okay. First, look at the constant function, or f of x is equal to k. This is our example. Let me draw the graph for that one. If you look at the graph, you can understand that there is a horizontal line here. In this case, it is difficult to talk about a tangent, as the graph itself is a horizontal line. The gradient of the line is obviously 0. So we can say that if f of x is equal to 2, then f dash of x is equal to 0. So this is true for all the constant functions. Their graphs are horizontal lines and they have the gradient 0. Am I right? So rule here is, if f of x is equal to k, it can be any constant, then f dash of x is equal to 0. Okay, let me show one more graph with 3 straight lines with different gradients. This graph shows 3 straight lines with different gradients. The derivative of the function is the gradient, and therefore we get this following result for each of the graph. For this one, gradient is 2 and y dash is equal to 2, and for this one gradient is 1, and for this one gradient is 1 over 2. So all first degree functions have straight line graphs, and therefore we conclude that if we differentiate functions of the form f of x is ax plus b, then we get f dash of x is equal to a. Okay. Now we will look at the quadratic function. First we started with a constant and with a x which has a degree 1. Now let's look at the second degree, which is nothing but a quadratic function. Okay, we can find the derivative by finding the average rate of change in an infinitely small interval. Okay, the definition of a derivative is, let's use this definition and calculate this using the function f of x is equal to x square. So f dash of x is x plus h the whole square. If you replace x by x plus h, you will get x plus h the whole square. F of x is nothing but x square and denominator is same h. Now you can expand this, a plus b the whole square, a square plus b square plus 2ab. X square and x square gets cancelled out and you will be left over with 2xh plus h square. You can also take h as a common factor outside and cancel it out with the denominator. Now apply the limit, h tends to 0, so you'll be left over with 2x. Hope you're clear with this concept. So this is what we get if we find the derivative of quadratic function. Let me take one suitable example and give you the formula for general case. Here is an example. F of x is equal to 2x square plus 4x. Let's differentiate this function. Let's apply the formula. F dash of x is, f of x can be replaced by 2x square plus 4x. And x plus h, just plug in x plus h in the place of x. Then you'll get an expansion here. Okay. So let's plug in those values in this definition. So I have just showed what is f of x plus h. Okay, let's plug in these two equations in this formula. Hope you're clear with this step. Now you have to apply a plus b the whole square formula and expand this one. Okay, 4 times x, 4 times h. A square plus b square plus 2ab formula here. Please be careful with this negative sign. So if you're distributing, you have to change the signs. Okay, so by simplification we will get, cancel out all the common factors and combine the like terms. So we will get, okay, these will get cancelled out. 2h square plus 4hx plus 4h. You can also take the h outside and cancel out with this denominator and give the final answer. Apply the limit, so you'll be left over with 4x plus 4. Hope you're clear with this example. Okay. Note that if we differentiate 2x square, we will get 4x, what we studied in the previous part. Now, we found that the derivative of x square was 2x. The line y equal to 4x has the gradient 4. So the derivative of 4x is 4. Adding these two results together gives us the result that the derivative of 2x square plus 4x is nothing but 4x plus 4. The same result as above. So from this example we can derive a rule which is easy to prove, which applies to the addition of the functions. If f of x is ax square plus bx plus c, it has the derivative f dash of x is 2ax plus b. Hope you are clear with this concept. Okay. Now let us move on to the next example where I am going to show you a denominator. Please consider this example. Differentiate the function 3x square minus 2x minus 1 over 4 divided by 2. Instead of dividing by 2, we can think of this example as multiplying each term by 1/2. Am I right? So we can therefore apply the above rules what we discussed in the previous example. Note that they only apply when dividing by a constant number. Okay. Notice also that the constant 1 over 4 has a derivative 0. The same as any other constant. So f dash of x is going to be 3 times 2x minus 2. This derivative is 1 and this is 0 divided by 2. Okay, now cancelling to simplify, we will get, taking 2 as a common factor out, you will be left over with 3x minus 1. Let us also discuss how to differentiate x cube, third degree function, and x raised to 4, and we can write a rule for the generalized case x raised to n. Hope you are clear with this example. Differentiate x cube. Okay. We have no rules so far for third degree functions, so we have to use the definition. F dash of x is nothing but limit h tends to 0, f of x plus h minus f of x divided by h. Okay. Just replace f of x by x cube and replace f of x plus h as x plus h the whole cube. Okay, so we will get, now you have to apply the formula or identity a plus b the whole cube. So a cube plus 3a square b plus 3ab square plus b cube. Okay, so apply that formula and expand this portion and cancel out the common factor. And we will be cancelling out with a denominator also. Let me show the steps. So this is what we get, 3x square. Hope you are clear with this part. Okay, now let us differentiate f of x is equal to x raised to 4 and check what we are getting. Okay, and then we can make a summary of all the examples we just saw. Second degree, third degree and fourth degree. Same concept. Take the definition, apply for f of x and f of x plus h, expand it, combine the like terms, cancel out the common factor. Here is the formula. Plug in f of x and f of x plus h. Expand a plus b raised to 4. Now check for the terms which can be cancelled out and combine all the like terms. Take the common factor h outside and cancel it with the denominator. And then apply the limit h tends to 0 for this expression within the parenthesis. We have h in all the three terms. So we will be left over with 4x cube. Hope you are clear with all these examples. Okay, so far the examples we discussed gives us the results. Okay, let me give the summary of all the results we got so far. If f of x is x raised to 0, it has the derivative 0. If f of x is raised to 1, then f dash of x is 1 times x raised to 0. Okay, which is equal to 1. And if f of x is equal to x squared, any quadratic function, then f dash of x is 2 times x raised to 1. If f of x is x cube, 3 times x square. If the function is x raised to 4, then its derivative is 4 times x raised to 3. So in every case, the result can be obtained by multiplying by the original index or power and decreasing the power by 1. Am I right? So this result can be shown to apply in general, and we can write the following rule. I'm going to write the rule for this one. This is nothing but the power rule. Am I right? Okay, power rule will be applied in differentiating polynomials. We will be applying the combination of all the rules. Okay, constant multiple rule, sum rule, difference rule, and power rule. Okay, let me give you a common example where you can apply the combination of the rules. Here is an example. F of x is this expression, and we are supposed to find the f dash of x. So find the derivative of each and every term separately. Keep the sign as it is and apply the rule according to the term given. For this one, we can directly apply the power rule. For this one, constant multiple rule. Take the constant out and apply the power rule. Same concept here. But for x, it will be 1. For constant, 0. For x square, 2x raised to 1. For x cube, 3x raised to 2. 4x raised to 3. 5x raised to 4. Hope you're clear with this concept. So by applying these rules, we will get, you can just do the algebraic calculation and combine all the like terms if possible. Give your answer in simplified way. Always start with the greater degree term. 4, 3, 2, 1 like that. Differentiating polynomials is one of the easiest concept. Hope you're clear with this concept. In case if you have any query regarding this topic, kindly let me know.